kind of talked about this on Friday, so I'm gonna kind of breeze through some of these questions. I won't do every single one. You're gonna be like, I get it, Mr. Erickson, I get it, we get it, okay? Stop doing more examples, right? So I did the word applied on Friday, right? There are two P's in there, and we realized that if you flip those P's, it's not a different permutation, it's not a different arrangement, they're exactly the same, right? So here we go. What is so important about identical objects, right? Identical objects means we need to divide out any repetition that may occur. Identical objects would be things such as marbles, shirts, and so forth. Letters, right? You can do letters and so forth. Same thing. But arranging people wearing the same color shirt or cars, same colored cars, unless they tell you that they're exactly same make and model and everything, they're distinguishable. They're not the same. Okay. So people for sure are unique, distinguishable. So no repetition here. Okay. The formula for the permutation arrangements, right? When you talk about permutations or arrangements that are possible involving identical objects, this is in general what it is. In general, you take the number of options you have, and then if you identify things that are exactly the same, you need to divide that out and make sure you always put a factorial next to it. You don't want to count, you don't want to double count a permutation if it's really the same as the one you already did. Okay, so here's the, why are the dot dot dot? Why are the, because there could be many repetitions, right? So you just got to watch out for that. So let's keep going here. Let's do a couple. This I just inserted here for you to keep in mind. From now on, this is a bit of a checklist. First of all, look at any restrictions that are present. Does it start with a B? So-and-so has to be with, at the front of the lineup, you name it. Second, there might be some grouping that may be mentioned. And then third, there might be some identical objects, right? So you need to divide that out. So these are kind of like the three things that I would watch out when you're doing permutation questions, okay? Note, the denominator will change depending on how many sets of identical objects are present, okay? So how many ways can the letters in the word eyes be arranged, okay? So repetition, right? There are two E's, okay? So n is the number of letters, right? So there's 4. Therefore, we're just going to go that there are 4 factorial ways of arranging those letters, but we have 2 E's, and so we're not going to count those as part of our calculation. So 24 is 4 factorial is 24, 2 factorial is 2, 12 ways. Okay, and I will highlight the E's and highlight the 2 down here. Right, it sticks out when you flip through your notes and you're studying. It's like, oh yeah, I remember that. Right, I remember that. Because you all study, right? I hope. How many in the word cactus? 2 C's. Right, 2 C's right there. Anything else that I'm missing? I don't think so. So n is number 1, 2, 3, 4, 5, 6 letters. It's not always going to be letters, but that's a classic. So 6 factorial divided by 2 factorial. Right, again, 2 C's, and that's what we divide out. And so we did Mississippi right on Friday. Yeah, that's like a good example, like sums it all up, right? So 6 factorial is 720 divided by 2, that's 360 ways. I just don't like typing factorials into these calculators. It's just too time consuming. So here we have repetition, 2 E's. If I miss something, please let me know, okay? 2 L's. Is that it? Yeah, I think we're good. So n would be 1, 2, 3, 4, 5, 6, 7, 8. 8 letters in this case. So we would go 8 factorial divided by 2 factorial, right? Like in this case, you have two sets of identical. I will highlight the first one like that, and the second one I will use a different highlighter just so you see that it's happening. What's 8 factorial again? 50, 40? It's 8 times 720, right? No. 40,320? Yeah. Divided by 2 times 2 is just 4, right? You gotta watch out how you do this. I don't know. I can see this happening, okay? Please don't do this. It's like, oh yeah, 40,320 divided by 2, right? Times 2. When you do this, the calculator is going to divide these, and then your answer is going to multiply by 2. So it's going to assume that 2 is up here. So you got to make sure that if you want to do it in one shot, you type it in with a bracket or something like that. That it's, yes, these two are multiplying, but ultimately that answer is dividing the top. Okay, so 10,080. There you go, 10,080 ways to arrange letters in that word. And you get the picture. Let's move on. I want to do the pathways question. Mississippi's right there. 27 though. I'm going to go the balloon question that I made up. I actually am always the balloon person when there's birthdays in our family. My wife just gives me a bunch of bags. Says like, you got the biggest set of lungs, you're going to do that, right? That's your job. I'm like, sure, I can do that. And so for this birthday, there are 4 blue balloons, 5 green, 3 yellow, 2 purple. Right off the bat, when it's something like this, you get the total, okay? So 4 and 5 is 9, 3 is 12, 2 is 14. So I'm going to make a note of that right away. 14 balloons, okay? And that's really n. N is the total number of options here. That'd be 14 balloons, right? He wonders how many possible combinations are possible if you were to tie them onto a string and hang them across the ceiling, right? So they're arranged in a row, right, across the ceiling. So how would that work? Well, balloons are non-distinguishable. Okay? You cannot tell them apart. So there's repetition happening here. So we'll say this. There are 14 factorial ways of arranging that string, but there are 4 that are blue, and you can't tell them apart. I mean, of course, I could have made a mistake. I could have made one bigger, one smaller, but that assumption, don't worry about that, right? 4 blue. Let's put blue under here. Okay. There are 5 green and 3 yellow and 2 purple. Okay. So I'm kind of, how about we circle them so that you know that this goes with that. We're taking care of the greens that are there, the yellows. So this, as you can tell, this is a bit of a crazy example, right? Like lots of things happening. But there are 14 balloons and we need to divide this out or else we're double, triple, quadruple counting, right? So here we go. I'm going to need my calculator for this one. And perhaps you won't be able to do it, in which case you need to know how to simplify, okay? So see how it's the E thing? I haven't done this one with a calculator in a while. So what I'm going to do is I'm just going to cancel out a bit. 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. I'm going to get this one down to where I get to 5 factorial because I see that 5 factorial here. And so we have the 4 factorial, the 3 factorial, and the 2 factorial, right? So this can cancel out. And I think now it's going to work out for me. You can cancel more. You can absolutely, this is just 2, right? The 2 goes in here 1 time. The 2 goes in there 3 times. And you're like, why didn't you pick 10? Why didn't you pick this one and 10? Yeah, you could have done that. It would have done the exact same thing, right? So 14 times 13 times 12 times 11 times 10 times 9 times 8. Oh, sorry, times 7 times 3. I forgot that part. So now you get this really big number, but now we can see 363, 242, 880. Okay, we're good. Divided by 4 factorial is 24, 3 factorial is 6, and the rest is basically gone. It's just 1. So I'm going to take this number, watch how I do this, divide it by, right, 24 times 6 in brackets, and so you get 2522520, okay? So 2,522,520 ways of arranging, okay? Okay, how many arrangements if same colors stay together? What's this saying? Grouping. Grouping. Now I need to tell you something. Like this always has to be done. Even if the question says there are no restrictions, it's saying there are no additional restrictions. This always has to be done. So in a sense, when somebody says, hey, how many ways can you arrange 14 balloons with these colors? They're saying this is how many permutations there are, period. There are no more than this many, okay? So if there's grouping, you need to kind of say that's on top of that. It's on top of that. So watch this. It's going to be a bit crazy, but you can handle it. So there's the first group, the second group, the third group, the fourth group. There are four groups because all the same colors have to stay together. You use my formula, total number of balloons minus all of this, right? How many groups are there? Basically count how many subtractions there are or how many factorials there are in front of it. So you need to add that many groups to it for this to work. Okay? 4 groups. And watch this. Are you ready for this on a Monday morning? We still need to divide out the repetitions. We still need to do that. So 4 factorial, 5 factorial, 3 factorial, 2 factorial. Do you see something interesting that's happening here? These are actually all going to cancel out. So watch this. Let's clean this up. So I'm going to go with a red pen maybe. I'm going to go this goes with that. This goes with that. This goes with that. This goes with that. Okay? So you're really left with, this is 9. You're basically subtracting everything, right? This is 14 plus 4. So you're really just down to 4 factorial, which is 24 ways. Right? Because you really only have those 4 groups, the 4 groups that can be shuffled. Within the group, does it matter if you shuffle within the group if they're the same color? No, it doesn't count as a different permutation. So you really are just arranging 4 things. So there's 24 ways of arranging them. Happy birthday if it's your birthday today. Mr. D's son asked him to paint a unique smiley face on each balloon. How many ways can be arranged now? What does this do? That word kind of gives it away, right? The unique. Right? Unique, which means distinguishable. Okay, we're now talking 14 distinguishable, unique balloons. It doesn't matter what the color is. So 14 factorial, and good luck with that, right? What was it again? Up there, right? So roughly 8.71 times 10 to the power of 10. So it's a really big number. If it ever comes down to this, I will be looking at just this. It's just a concept, right? You understand what this does to the question. Okay? There are no repetitions, so you don't need to worry about dividing out. Let's add a layer to this. You ready? What if I said everything has a smiley face, but you want to keep the same colors together? Everything has a smiley face. You want to keep the same colors together. Technically, if you just go up to this question, you would just not have to worry about dividing out repeated elements because they're all unique, right? So the grouping would still remain, but you would not have to worry about dividing this out. Okay. We don't have enough room to do that, so I'm just going to leave it, but I want you to be aware of that. Okay, let's move on. Mississippi's right there. We've done that. What should I say here? What page did we do that on? In the C page, C notes on page. Can you give me that page number? I don't know where I asked you to write it down. Somewhere, right? It was in the booklet. 17, 19. Anybody have that booklet handy? No? Okay, I'll figure it out later. I don't want to dig see page 17, 19, somewhere in that neighborhood. So we'll leave that for now, okay? If you want more of grouping and identicals, there's your homework, right? So I kind of pick it out just to pertain to that. This one here, we did something like this on Friday. I will leave that for now. I'm thinking if you should do this for homework, but there was textbook homework on this. I actually specifically gave you homework for more of these. So do that, okay, go back. And now I need to get a new booklet because I wrote on this one. We're going to do something that's a little different, but it still talks about, so this is page 32, pathways. I'm going to stop the video here once and just